It's not easy for us busy geotechnical engineers to keep up with industry trends while keeping up with our engineering work. Therefore, it's our goal that the Geotechnical Engineering Podcast can help you do just that. We strive to keep our listeners informed with important industry topics and also to educate you on interesting technical topics and trends in the geotechnical world. In this episode of the Geotechnical Engineering Podcast, I'll be talking with Dr. Roy Mayfield, PE, a principal geotechnical engineer with BGC Engineering Incorporated, which is a consulting company focused on the geosciences. We'll be talking to him about his involvement in mine tailing dams and how we can help to improve the safety of these dams, as well as why having a sound engineering judgment and expertise is crucial to your engineering career. I'm your host, Jared Green, and I'm excited to be bringing you another episode of the Geotechnical Engineering Podcast.
This video is brought to you by Colliers Engineering and Design. Colliers Engineering and Design provides multidisciplinary engineering, architecture, design, and consulting services to public and private clients. Their comprehensive suite of services offers everything from civil site development to transportation and energy through a nationwide network of offices. Colliers Engineering and Design values their employees and takes pride in their culture. With a focus on professional development and a family atmosphere, some of their offerings are a comprehensive mentorship program, a hybrid work environment, and competitive benefit packages. For more information about how you can join their team, find them on Twitter, Facebook, Instagram, and LinkedIn, or visit their website at colliersengineering.com.
Welcome to the show, Roy. How are you doing?
I'm doing very well. Nice to be with you.
Ah, great. Glad to have you on the show. Can you tell our listeners a little bit more about yourself and what is it that you do on a daily basis?
Yeah, so I grew up in a small town up in the middle of British Columbia, Canada, Williams Lake. It's a ranching, logging, mining town. My dad was in logging and ranching. I don't really know how I got the idea that I was going to be an engineer. I didn't really know any engineers, but you know, the usual thing, good in math and physics and all that stuff. And when I got into engineering at the University of British Columbia in Vancouver, I thought I'd made a terrible mistake. I did not like the early classes, you know, the thermodynamics and the statics and the electricity and all that stuff. But as the courses got to be more engineering, I enjoyed it a lot more. I finished up, got a job with a geotechnical consulting firm in the Vancouver area. And they had done some previous work, like obviously years before I started with them, with Terzaghi and Casagrande. So they operated a very high level. And for me, it was like drinking from a fire hose, learning all of this stuff and how these guys did what they did and still do. And I got assigned to the mining division, working on tailings dams, my first exposure to that. And I loved it. I mean, it was just wonderful. My first exposure to soil liquefaction, which has been sort of my passion or love throughout my whole career. And yeah, I still love it. I mean, I'm really intrigued and excited about the work I do. So other than a few little hiccups along the way due to soft economic times, I've been in engineering consulting for my whole career, geotechnical consulting, mostly in the mining industry. I had a strange set of circumstances come about when I'd been in the business about 20 years, and I went back to grad school. I did my master's degree at the University of Washington with Professor Steve Kramer, and when I was done, he asked me to stay on for a Ph.D., which was like totally unexpected and nothing I'd even considered. I mean, even going back for a master's degree was pretty out there for me. But I talked it over with my very tolerant wife, and we decided that it was a good thing to do. And truly, it was one of the best decisions I've ever made, other than, of course, marrying my very tolerant wife. Yeah, so that was great. After I was done, I defended my dissertation the week before I turned 50. So it was maybe not quite the standard path through university, but it was fantastic. Anyway, I joined up with a colleague that I'd met in my first job after my undergrad, 20 some years before, who had started his own company, BGC Engineering, and I've been there ever since. My work now is mostly reviewing. I review BGC project work, reports, quality control on reports before they go out the door, dealing with the project team's decisions that are made along the path of the project. I'm also doing quite a bit of work on external review boards for tailings dams now. So client will form a review board to review their engineer's design, their operations, construction, the whole package that's ongoing. So I spend a lot of my time reading and writing, which is ironic because one of the big attractions for engineering for me in high school was that I didn't like English and I didn't like writing, and now I spend my whole time in that. So
Yeah.
I've gotten over that, and I really enjoy the process of organizing my thoughts on paper and seeing ideas basically come to life.
Wow. I love it. What a story. What a story to be working. And I know it's not a story. You're like, this is my life. but to
Everything's
be
a story.
Yeah, to be working for 20 years and then go back to grad school and then go on to get a PhD and defend before. I mean, that's pretty wild. You don't hear it that way, right? But no, that's great. Thank you for sharing.
It worked out well.
Yeah. And I'd like to talk more about the mine tailing dams. So, you've had involvement on a lot of these projects. And, before we get into that, can you tell our listeners that might not be very familiar with what that even is? Talk through what they are, what they're used for, and then, how does that lead to geotechnical challenges? I think that would be helpful for a lot of listeners.
Yeah, sure. So mine tailings are what's left over after the target mineral is removed from the ore. So for example, in a copper mine, the mine will dig rock out of the ground that they've determined has a certain amount of copper in it, usually maybe less than 0.5% of copper. They crush up the rock and grind it down till it's about the size of fine sand or silt. And then that's to get lots of surface area so that the reagents that they apply to the material can get the copper off. And so once that's happened, what's left over, all the sand and silt-sized particles with the copper removed, is tailings. That's what comes out of the tail end of the process plant, in effect. And this processing to get the mineral out is usually done in a slurry. There's lots of fluid. So you have this slurry of sand and silt that has to be stored, impounded. And in processes where there is where the tailings have a fair component of sand in them, the sand can be stripped out and used as a construction material to actually build the embankments that impound the tailings slurry. Now that obviously takes a little bit of care. I mean, we've known for a long time that wet sand can behave very badly. Even like in the New Testament, there's the story of the wise man and the foolish man and building the house on the rock and the sand. So we've known this for a long time, but it's very efficient. It means that the impoundment, the volume that's stored, can be smaller because you're using part of that material to actually build the embankments, and you don't have to tear up more land, digging up borrow material to build the dams. But it is sand, and there's some great care that's required in the process.
Okay. Thank you for that. And so, so we have the mine tailing dams. Now, when a mine tailing dam fails, the results could be catastrophic. So
Absolutely.
What are some of those consequences?
Yeah, tailings dams are some of the largest man-made structures in the world. I mean, they're very large, and the consequences can be very severe, just like the consequences of a water dam or a bridge or a building or any other civil engineering structure that we're involved in, fails. Sometimes the impounded tailings have some bad chemical properties, and so if the dam breaks and these tailings flow out onto the surrounding ground, there can be some chemical contamination. But even if the tailings are relatively benign, just the sheer volume of them flowing out, often when a breach happens, the tailings will undergo liquefaction and they will flow out like a slurry. So it's not just like bloop and they're at the toe. And so, millions and millions of cubic meters of tailings can flow out and bury the surrounding ground. If anybody that's seen the videos of some of the tailings dam failures in Brazil, the downstream effects are very apparent and tragic.
What are some of the things that could be done to improve the safety when you're talking about design or construction and tailing dams?
Yeah, well, like most geotechnical failures, water is involved in the problem. And so geotechnical engineers need to be very integrated with the hydrologists, the hydraulics engineers, the hydrogeologists to understand how the water is behaving in the impoundment. So it's very much an integrated team. Geotechnical engineers on their own need to better understand the undrained behavior of sand. Quite often, in the older days anyway, people thought that, sand behaved in a drained manner. You use drain parameters for that. You don't use undrained parameters. That's just clay. But that's not true. We know very clearly that sand can undergo liquefaction and behave in a very undrained manner. It can flow. So recognizing that saturated sand can lose strength when it's sheared, and that strength loss can be very quick, and a very large proportion of the strength can be lost, and the behavior can be very brittle. It's not something you necessarily can monitor for. There's no time to react when this happens. So just understanding all of that behavior and building it into a robust design is very important. But it's not all about engineering. Tailings dams are often built over the life of the mine. They don't build the whole dam at the beginning and then fill it up, as the tailings come from the process plant. That the dam is raised over time. There's a lot of advantages to that. You have the time to gather more information about the site, see how it's behaving. You can optimize the design. You can history match your design with the performance. But there can also be a sense of business as usual. You can say, yeah, we see this all the time, even the warning signs, and yeah, that happens and we're used to it. And so that's a process that is sometimes called the normalization of deviance. And so the systems that are in place have to be aware of that. And all the way up to the board of directors, you have to be aware of this complacency that can set in. And so you need good systems in the engineering, in the construction, and in the operations, and that has to extend into plans through closure as well. So all of those things have been touched on in the recent document that was put out, the Global Institute for Tailings Management. I'm missing a word in there, but it came out in 2019 in the aftermath of the Brumadinho tailings dam failure. And that focuses on this integration and the systems that are required to improve tailings dam safety. It's a piece of paper, it's a document by itself, it's not going to do anything. But I think as tailings dam engineers and operators accept this and build it into their daily operations, that will go a long way to reducing tailings dam risk.
Thank you so much for that. And you've worked on, or directed, I should say, many large geotechnical projects in the past. Can you tell us a little bit more about a project? Let's say if there's one project that stood out in your career, and what did you learn from it? It's hard to choose just one, right?
Well, it is, and yeah. So I guess one that touches on the integration and understanding the purpose of our work. You know, when I was first starting to lead engineering projects, one of them was at a small mine in the Southwest US. And they didn't have a big engineering staff, so I was dealing with the mine manager there, a fine fellow and a pretty sharp engineer in his own right. And so we presented a design for this impoundment. And he looked at it and he said, I don't like what you've done in this one area, this one corner here. He said, I think you're being way too conservative. And after a while, he came back and he said, this is what I think should be done in this area. So, you know, I very much respected his opinion. And so we looked at it and just didn't think it was going to work. We thought it actually might not stand up during construction. It might slide. And so kind of went back to him and said, sorry, Brian, but we want to stay with our design. And he bit it back and forth. And finally, he looked me in the eye and he said, Roy, okay, I'm going to build my design. And if it doesn't fail, if it stands up, I'm going to take out a full-page ad on the back cover of the Mining Engineering magazine. And I'm going to tell people how conservative you were and how much money it would have cost me. And so get ready. And I was like, wow, that's pretty heavy, Brian. I mean, usually he didn't, you know, go down this kind of path, you know, applying this much pressure. But so we went back and looked again, and we're really couldn't see our way through to accepting his design. So I dug my heels in and I said, I just can't do it. You have to build our design. And bless his heart, he didn't throw us off the job. We stayed on, but we weren't on site during construction. A few months later, I did go to site for some other business, and when I was there, I looked at this facility we designed, and I was pleased but surprised to see that he'd built it according to our design. Wow. And I just thought, oh, he was just riffing on us. He was just, you know, pushing us to try and take some fat out of the design, wanted to save a few nickels or whatever. And I was giving him a bit of a ribbing about it. And he said, no, that's not the case at all. He said, I actually built my design, and like you said, it didn't stand up. Wow. So I had to dig it out and rebuild it. He said I had some other stuff going on next door to here. And if I'd built your design, I would have had to have shut that down. It would have cost me a lot of money else, you know, for this. And so I felt it was worth the risk. So, you know, I could feel good in the fact that our analysis had borne out the correct prediction, and that our design was in fact better. But I really felt bad that I hadn't appreciated the jam he was in, and that I was thinking about, you know, his design versus my design, this competition, when it really shouldn't have been that way. We should have been looking for a third option that would have addressed his needs and yet stood up during construction, obviously. And so it really made me realize that, you know, what we do is only a small part of the bigger picture. There's a lot of other stuff going on. And also it made me, I try to remember that reasonable people don't usually make unreasonable requests. And when they do, when they make something an unreasonable request, or they're acting in a way that seems unreasonable, there's something behind it that we need to try and understand and incorporate in our work.
That's just really good counsel. I think that you know, understanding, you know, whatever the boundary conditions are, or the constraints that may not be articulated, it's like, if you have an appreciation for that, then all of a sudden it's like, it's not the client's problem, it's our problem, it's our challenge. So there's an opportunity here, let's find it. But oftentimes you're right, it's your design versus my design, and we're not truly collaborating if we're not getting that last piece. That's really good counsel there. And thank you for sharing that. That's I can see where that would end up being that one project, you know? Wow.
Well, It's funny
Yeah.
how we seem to learn best from things that don't go well, but I guess that's the way we're wired.
It's the way we're wired. You never really see that project where everything went perfect. You know, it's like it's the ones where you just had little nuance here or there that you learn from. So that's good.
That's right.
And I think that that's a good segue for what I want to talk about next. I want to talk about engineering judgment. I remember when I was in school, they used to talk a lot about engineering judgment, but engineering judgment is critical to effective engineering practice, especially when design thinking is required. So what would you say that engineers can do to develop sound engineering judgment and expertise? I mean, what would you say that they can be doing or should be doing to acquire that?
Yeah. So you've probably heard the old joke about the young engineer who asked the old engineer, how do I, get sound judgment? And the response is, well, through experience. And so the young engineer comes back and says, well, how do I get experience? And the response is through bad judgment. So it is we do learn through our mistakes, but individually and through the profession, we can't afford to just learn through mistakes. I mean, we can't just make mistakes and learn from it. The legal profession has a say in that, and our clients aren't very appreciative either. Correct. So we do need to study very carefully case histories where things have gone wrong, and understand what happened and how we can avoid those things. But also, we can develop judgment by thinking about what we're doing in our day-to-day practice in a more rigorous way. One of the guys that taught me how to do slope stability analysis, he said, when you draw up your section and first get it going, get all your material layers on there, your pore pressures and all that stuff. Before you do any analysis, take your pencil and draw where you think the critical slip surface is going to be, and write on the section what you think the factor of safety is going to be from the analysis. And then start doing the analysis. And if you're way out, go back and understand why you were different from the analysis. Sometimes you'll find that you messed up the analysis, that something was wrong in the input. I mean, it's just a check. But learn what's important in the analysis from your mind so that you can start to look at things and just see what to expect, what makes sense. When you go through your stability analysis, you're always changing things. And so predict what the changes will be. Look very closely at what you're doing and say, okay, this is going to increase my factor of safety by 0.05 or something like that. Do the analysis and then calibrate yourself as you go along. As you do that more and more, you get, doesn't take very long, but with this idea of competition, of challenging yourself. I mean, he used to bet me coffees on this. We'd both put our numbers up there, and you very quickly understand in whatever type of analysis you're doing what's important, and so you can put these scenarios together, these sets of conditions that you've looked at, and you've looked at in quite a lot of detail, and you can have these I call them images or scenarios or maps or whatever that you accumulate in your mind, so that when something similar comes up, you can apply that image very quickly. You don't have to go through all the steps. You have this image that you can apply in your mind, see the differences, and then from your understanding of the analysis, go, this difference is important, this difference isn't so important, this is what I might expect for this situation. Now, as you accumulate a library of these images, you get to be very adept at judging situations and judging the important characteristics of a situation that where you need to spend your attention, your money, your effort. I've read that experts do this, and they are able to very quickly just look at a situation and come up with the answer, where the rest of us are still kind of floundering around trying to understand the situation. So that rigor in the day-to-day work that we do, understanding what we do, understanding what's important, I think is a great way of developing engineering judgment.
I love it. I've never heard it said that way. I love it. Love it. Well, before we take our break, what's the final piece of advice you'd like to give some of the younger listeners when dealing with uncertainty in their careers?
Mm. Yeah, uncertainty. We often, as we go through, our university studies, it's a survival mechanism, really. We learn, okay, what's the formula we need? What input do you need for that formula? Here's the input, plug and chug, boom, next problem set. We kind of work through things like that. But analysis isn't design. And we need to develop robust designs. It's very hard to assess the effect of our uncertainties unless we actually go through the analysis. A lot of building code designs use, say, the 2% and 50-year earthquake ground motions. Like, that's a return period of about 2,500 years. A lot of dams that I work on use 10,000-year return period ground motions. Now, those are very, very small probabilities, and most of us don't have a lot of experience in developing judgment with those very, very small probabilities. We might do a site investigation program, get a range of values, and go, oh, well, I'm not going to use the mean or the median. I'm going to use mean minus 1 standard deviation, or the 30th percentile, or the 16th percentile, or whatever. But when you think of like the 16th percentile versus the 1 in 2,500 year, the 1 in 10,000, there's a big difference in there. I'm not saying you should always use lower bound strengths or anything like that. That's not what I mean. But I guess just understanding the range of values, understanding even if our investigation has covered the possible range of values that we might see. We drill holes here and there. It's like building a jigsaw puzzle with when you don't have the box and you've only got 8 pieces of a 500-piece puzzle. We operate on a very, very slim data set in many cases. So just being very humble about what we know, doing the extra work, doing the extra analyses to say, well, if we did have this, what would happen? And then thinking about even crazier combinations that might come up. You're not going to set those as the design case, but you need to understand how robust your design is in case of unexpected circumstances.
Well said, well said. Wow, so lots to chew on here. Thank you so much. So we're going to come back in just a minute and close this one out with Roy in our Career Factor Safety In segment. Stick around.
Before we go on here, I would like to take a minute to recognize our other sponsor for this episode, Menard USA. Menard USA is a specialty ground improvement contractor that works nationally, providing design-build ground improvement solutions at sites with problematic soils. Menard works closely with civil, structural, and geotechnical engineers to minimize foundation costs for wide ranges of soil conditions, structure types, and loading conditions. To learn more about Menard USA or for help on your next project, please visit www.menardusa.com.
Welcome back. It's time for our Career Factor Safety In segment. In geotechnical engineering, just like many disciplines of engineering, it's important to incorporate a factor of safety into your design. But what about incorporating a factor of safety into your career? Today, of course, we're speaking with Roy Mayfield, Ph.D., PE, a principal geotechnical engineer at BGC Engineering Incorporated. Roy, you've already had a very successful career. Now, when you look back at your career, is there something that you've implemented into your career to give yourself a factor of safety in your career?
Yeah, engineering work is almost always teamwork. In my view, a career factor of safety means being in demand. When not long after I started work with this geotechnical company after my undergrad, and the economic times got pretty tough, and that involved some layoffs. And so it was pretty clear to me at an early stage of my career that being in demand was important. And that doesn't always mean being the superstar, the best analytical person on the team. A big part of it is just being a willingness to do the work with some energy, putting your hand up, being available. This wasn't really too hard for me because I've really loved what I've been doing. So I was more challenged by saying no than by saying yes. So I think there are times when the work isn't all that exciting, but there's usually something in there. Make it a competition, somehow make it interesting so that you can bring energy to the work. Another big part of it is meeting your commitments. If you say you're going to get the work done in 2 days, get it done in 2 days, and be reliable so that people can count on you. That's a huge part of being in demand. Most of all, though, I think you want to try and make the team you're on successful in whatever way you can. We all need a wingman, and it's best if we don't begrudge our time.
Well said,
if you can build those into your approach to work, then you will be in demand for more work than you can handle. And that means you might get to choose between a couple of different options and have a better opportunity to do more of what you like.
Excellent. Well, thank you so much, Dr. Mayfield. Thank you for coming on the show and sharing so many great insights with us. You share great information and advice. It's going to be super helpful for our listeners. If a listener wanted to reach out to you, how can they find you? In your social media, or you want to share an email address? How can they find you?
Yeah, I'm not very much into the social media, but but my email address is rmayfield@bgcengineering.ca, the Canadian-based company. Reach out there, and I'll do what I can.
All right, great. Well, thank you so much for coming on. This is awesome.
Pleasure.
I hope you enjoyed the episode today. We would love to hear your feedback, comments, and/or questions. Please feel free to go to geotechnicalengineeringpodcast.com, where you'll find a summary of the key points discussed in today's episode, that being episode 51, as well as links to any of the resources, websites, or books mentioned during this episode. Until next time, we wish you the very best in all your geotechnical engineering endeavors. Peace.